intimate, and it's a lot of fun meeting with everyone here. My name is Dave Stanich, and you're here to listen to Reduce, Reuse, Recycle your framework code into web components. And the reason I got into this is kind of my strategy for learning something, and that is to, oh, I said that, never mind. My strategy for learning is to always pick something that I'm interested in and then kind of commit to a date to educate others either at work or at a conference, and then that gives me a deadline and then force myself to learn it by that deadline. So what I'm going to show you isn't necessarily what we're using in production, but what I found in that research and then potentially what we might use in production. So a little bit about me. I'm a software engineer at IBM in the Watson Health division, so it's a kind of newer division that IBM has. I'm located in Rochester, Minnesota. I'm mostly front-end based, but in my career I've done stuff like OS level development all the way to front-end. And I feel like I prefer the front-end side because you can see changes right away. Everything's changing in the industry, which is kind of fun to keep up with. And it's just a lot of fun working with designers and other people that get to use your interface every day. I primarily use Angular. We just started with React as well. We do a little bit of Node and a little bit of Java, but I'm trying to kind of keep that at a distance now. I'm also an advocate of continued learning and community building. So the fact that you're all here is fantastic. I also encourage you, if you don't already do this, to go to some local meetups and learn things outside of business hours, because you kind of network and learn from other people. As part of that, I co-organize a meetup inside of IBM Rochester called Fed at IBM, which is front-end development at IBM. And if you have a large enough company, I encourage this kind of behavior because you start networking with people in your company that you didn't even know did front-end development, or maybe they're back-end developers and you really had no clue that they liked front-end development, and so maybe they could even join your team eventually. You can follow me on Twitter here, GitHub. All the repo information will be posted later at the end of the slides, but I'll also post it on Twitter at dstanich, or you can look at the hashtag MidwestJS. So what I'm going to start with is a problem. And the problem is kind of illustrated by this. This is my career UI framework history, the last 14 or so years. This is both desktop and web app technologies that I've used to build applications that are UI based. And the size of this, each bubble is how long I used it. So what's the problem? The problem is there's way too many changes here. I mean, this is only like 3 companies and maybe like 4 projects, and we're somehow using all these bubbles. And so our industry is rapidly changing, which all of you probably know this. Frameworks and libraries come and go at a high rate. Apps often live longer than the libraries they're built on. Has anyone ever had an app that was running on something and then that package got deprecated, like AngularJS or anything like that? I see some head nods, yep. So our library, or our application, has actually been rewritten a few times because of that. So it's a long-lived application, and just something happens in the framework, and then we get a new design from our design team, and instead of using that same framework, we rewrite it. So there's a lot of churn that goes into that. And just 2 quick examples of illustrations of this are the State of JavaScript survey. Has anyone in the room seen this before? It's a few hands. So if you haven't seen this, just go to stateofjs.com, and they've done this, I think, the last 2 or 3 years, maybe a little bit longer. But it goes into detail about the people's responses of what technologies they're using. It's obviously skewed by the demographics that answer, right? So if only certain people answer, it's going to be skewed, but at least it gives some sort of trend line that you can see. And if you compare year to year, you can see growth in various technologies or decline in others, right? AngularJS is starting to see a decline here. And then another one, a lot of you in the room might be familiar with Front End Masters, which is a local Minneapolis-based company that has training, good front-end training. They have this booklet that they publish every year called the Front End Handbook, and this goes into detail on kind of what happened in the last year in front-end development, and then what they predict might happen in the future. And there's links here that you could go and click and read about everything. And the interesting thing here in 2019, when they say what they might predict might happen, they talk about web components. And I think this is echoed with a lot of people. Really, no one has any clue how web components are going to play out. They go in these like hype cycles. Sometimes they're really popular, sometimes they're not. And that's kind of what I'm going to talk about today. So this change, how does that impact developers and companies? For developers, I kind of think of this as a three-phase approach. The first phase is you start to get stale skills. If your company or application is not using a newer framework, but the rest of the industry is moving forward, you might develop those stale skills. And then the second phase would be you start to have lower job satisfaction. You know, maybe you want to go learn those skills and you want to apply them on the job, but you can't. And then finally, I guess my phase 3 is you leave. So a lot of times you just leave a company because they can't handle using that new technology for various reasons, you know, monetary reasons or other things like that. But it's not all on the company, right? They're trying to make money. And so from their side, they want developer interchangeability, right? If they have 3 different apps and 10 developers, they want you working on all 3 of those apps, right? It's not helpful for them if you can only work on one thing. And so if you're using 2 or 3 different frameworks, that really limits that for you. And then I mentioned this a little bit earlier, most companies can't justify rewriting something that is just going to be exactly the same. So if you try to go to your boss and say, I'll rewrite this in, you know, React++ or whatever the new thing is, it'll look exactly the same, no one will even notice. It's probably wrong because you're going to have more bugs than you had before since you're learning it, and then also you're not fixing those problems that you hardened into that old application. So companies can't justify that. And then it's really hard to attract talent if you're using something that's older and people don't want to, you know, use anymore. So you may end up having to pay a premium for a developer that wants to work on an older technology because you don't have as large of a pool to hire from. So change, it's really impactful. And so a potential solution for this is what we're going to see here is what's the constant in this. And the constant is just regular old JavaScript. So no matter where I was doing development, I always use JavaScript in some form, just regular old browser-supported JavaScript. And so what if there was something in regular JavaScript that could help this? You know, something maybe in the title of the talk, and that is web components. And so just out of curiosity, who has heard of web components? Okay, most people. Who uses them in production? Okay, 1. So I've given this talk maybe 2 or 3 times, and that's generally the response. There's always like 1, 2, 3 people that use them. And I think they're about ready to be used. And you'll kind of go into some details on what they are briefly, and then we'll talk about an example and then how they relate back to the JavaScript frameworks that you're probably using today. And so just a brief definition, they're not one thing. They're actually a set of standards and APIs. And they allow you to create custom reusable encapsulated HTML tags for web pages or web apps. So these are the specifications. This is, you know, a true definition of web components. In my opinion, the first 2 are the most important. The other 2 maybe you don't necessarily care about, and my examples are actually not going to use the last 2. But when you think of web components, you're probably thinking of custom elements. And this is really the main thing behind a web component. And what you see here is you see custom elements.define. I give it a tag name, and then I give it the class that will be instantiated when that tag is placed on your page. And it's really simple to make. You just make a class that extends HTML element, and then there's some lifecycle hooks and other things you can hook into to make a web component. And I'll have a demo here in a minute. And then a shadow DOM, which you may or may not have heard of, it's also kind of a popular term lately, is a way to encapsulate your styles in a section of the DOM so that nothing else can really interact with it. And so here's just a brief example of how you would attach this in just vanilla JavaScript. You just create an element, and then you'd attach that element with the shadow DOM, and there's a mode, open or closed. Open allows things outside of it to get inside your shadow DOM. Closed means you can't. And I forgot to mention, as I go through these things, think about how they relate to React, Angular, or Vue, because these are very similar concepts to what you use today, and you're not even really, you know, it's easy to relate back to this, I guess is what I'm saying. So try to think about how they relate to your framework of choice. Then ES modules or imports. You are likely using imports like this today in Angular, Vue, React. It's also a vanilla JavaScript concept, so this isn't really news to most people. But when you write this in your favorite framework, it's really transpiling it to something else. or Webpack is kind of combining it for you. But eventually, most browsers will support this kind of imports without any kind of transpiling. Then HTML template, most frameworks have this concept where you have a tag and you can put stuff inside that tag, and then nothing else gets rendered from that tag until you put this inside of another element. Okay, so browser support, you're going to ask this because that's usually what comes up when you talk about web components. So Firefox and Chrome mostly support all the things I just mentioned, except for the imports. Safari has partial support for most things. You can't extend an existing element. Edge and Internet Explorer, of course, don't support any of this. However, if you don't know already, Edge will eventually be Chrome-based, so this is not going to be a problem anymore. And just real briefly, I'll show can I use for people familiar. If you type web component, like I said, it's not one thing. You get a list of 4 different things here, all of which I mentioned. And then at the bottom, it aggregates those and says, this is the browser support statement for those 4 things. So it's actually a unique thing. I've never really seen that before in other searches on can I use. So let's go ahead and look at a demo of this. What I'm going to show is a very vanilla way to make a web component. There are much better ways if you were going to go strict web component to make these things, but I just want to show you what a very vanilla, no library way of doing this would be. And so I'll tweet this out after, but this is sort of a landing page that has all the slides, the example repo, has notes on what I'll do when I export these, and then links to all live demos if you want to see this. And so I'll tweet this out, and it'll be later in the slides here too. But my go-to when I make a demo is always football, because I like football. And I'm a Packer fan, though, so Packers are going to win a bunch, Vikings are going to lose a bunch. And so this is my demo. And you'll notice that there's repeated things here, right? And so a web component that I made is for these boxes. And it's called a win-loss counter, I believe is what I called it. And so that's repeated 4 times on this page. And so we'll show briefly how to look at that here. So if you look at the repo afterward or now, there's directories that are labeled with numbers. So if you step through these in order, it kind of shows the progression of these demos that I'm going to give. But the first thing here is, again, this is just very basic web component. You'd import a script just with a script tag, which has the web component inside of it. There's some styling, which is not really relevant. And then the things I want to point out here are this messages div, which is this thing at the top that says Lions have 4 losses. And then there's cards for each one of those teams. And inside there's a win-loss counter. And so this is not a native HTML element, right? It's a web component. And so I can pass in a team name, I can pass in a color. These are just attributes that my web component is accepting. And then there's also a concept that you may be familiar with. In Angular, it's called transclusion. I don't know if it's called similar things in other frameworks, but I can put something between those tags, and then the web component is going to tell the DOM where inside of the web component I want to put this cheese logo. It's easier to just use an emoji than an actual logo. So I'll show a demo of that in a minute here, and then there's a change color button and a remove button that illustrate various lifecycle hooks that a web component has. So looking at the code, I mentioned I'm not using templates, and I'm not really using the ES module imports. So here I'm just inlining a template just for reusability. But here is the styles for this web component, and then the actual DOM for the web component. And here, remember I mentioned there's something called a slot. Well, I'm saying that anything that is in that slot in the previous example, in that HTML, I'm putting right here on this page. And I can pick to put that wherever I want. And so again, that's very similar to framework concepts that you might be using today. Then there's some various divs that have IDs, so a team name ID, wins, losses, there's a win-loss button. But the real meat of it is down here. And so what this is it's extending HTML element, just like I mentioned earlier. And then there's something called observed attributes. And excuse me, in observed attributes, I'm saying when one of these attributes changes, you tell me, and then I get a lifecycle hook, and it will update that lifecycle hook, and I can change something in my DOM. So here I'm saying when color changes, I want it to be notified. Excuse me. So here, most frameworks have the concept of on init or some sort of initialization constructor. This is Web Components' version of this. When it's created, connected callback is called, and you can create whatever you want inside of your DOM, inside of that, that web component. So here, remember I said it's very, very vanilla. Most people hate writing code like this, including me. You know, doing document.createElement, right? It's just terrible. The amount of code that I have to do to make just that simple UI that I showed is very large. So there are other ways to do this, but I'm just showing you a very vanilla approach here. But what I do is I get that template, I inject it into a div, I attach a shadow DOM, which I mentioned before, and then here we're getting the attribute, which is team, the attribute color, and then we're setting some styles and some inner text of things. Then we're setting up a click handler on the buttons so that we know when something's clicked so we can inform our parent. Then there's a lifecycle hook for disconnected, just like a destroy lifecycle hook that you might be used to. There's one for moving if you were moved on the DOM. And then there's one for the changed callback. So remember in observed attributes I said I wanted to be notified when color changed. Well, now it's going to call this thing, and I can do whatever I want with that new value. So it passes in the name of whatever was changed, the old value, and the new value. And in this case, I'm changing the background. So if we head back over here and I change this to gold, we can see in the console it's outputting some logs here, which we'll see in the code. So it's very similar to things you have just in normal frameworks. And then there's an increment count, which is what the buttons actually call when you click those. And the way a web component event works, you know, in Angular you have outputs, you know, in React you might have callback functions, in Vue I think there's event emitter type things. In web components what you do is you just dispatch a normal DOM event. So this could be just a normal event, or in my case it's a custom event. I want to output saying the record of this changed, and then the parent can handle it however they want. And then just one more thing here, what we are going to do is, if you look at the bottom of this index file, it hooks up a event listener, just the way a normal DOM event listener on record change, and it will update the messages to have that new information in it. So there's nothing framework involved here. Excuse me, I don't know what's going on here. Does that make sense? There's very similar things to what you're used to in a framework. So I already talked about a lot of these, but there's a reusable component. It's HTML tag based. There's inputs and outputs. There's lifecycle hooks, and you can style encapsulate things. These are all very, very similar to React, Angular, and Vue. So if they're so similar, why can't we utilize this in our applications, right? Maybe there's some way we can marry these concepts. And that's where export to web component comes in. And so the reason I got interested in this was the Angular team released something called Angular Elements, which allows you to take an Angular component and export it as a generic web component. And I thought that was really cool, and so I started researching the other frameworks. And there are abilities to do this in all frameworks, and it's kind of a growing thing that people are starting to do. And so I want to talk about this as we go through here. Before I do, just out of curiosity, so I can maybe focus on a little bit more areas compared to others, who uses Angular in here or wants to use Angular? Okay, what about React? Okay, and then Vue. Okay, that's helpful to know. Thank you. And so what these wrappers do is it takes your JavaScript framework component, it puts a wrapper around it and basically acts as a translator between the browser and your JavaScript component. So you still have to import a minimal runtime for your framework. It's not like it's transpiling it down to vanilla JavaScript. So there is some overhead in doing this, but it does allow you to use it as a normal HTML element without other frameworks even knowing that you're doing that. And it also converts inputs or props to attributes or properties. It depends on the wrapper on how it's doing that. And there's wildly different levels of maturity in these technologies. So we'll see, but Vue by far is the most ready to use this, and then the other two are kind of lagging behind. But there's developments all the time in this. So some use cases, why would I ever want to do this? And in my opinion, the first two are why you would. Upgrading to a newer technology. So if you had AngularJS or or knockout or something older and you want to update it to something newer, you could do this sort of piecemeal. You could take maybe a table on your page that's using something old and maybe rewrite it in React or Angular or something, and then take that rewritten version, export it to Web Component, and then stick it on your AngularJS page, and no one would know that you're using a different technology behind the scenes. It's going to obviously, impact your bundle size and that kind of thing, but if this is a temporary upgrade path, you can do this very transparently. The frameworks don't have to know about each other. You could also keep investment in older code. So say you have some sort of really good application that's making tons of money and you don't want to touch any of that code, but all your new applications are written in React, but you want to add something to both the new and the old without having to write it twice. Well, you can do that by writing it in the new technology and then exporting it and then using it in the old technology. Could also embed it in frameworks that typically are harder to embed things in. Yeah, I'll get to that at the end, but yeah, there are some concerns there. And the question was having to have something that's using something like state management software and other dependencies. And we'll get to some of that, or we can talk afterward. But there are some complexities there and bundle size concerns. But basically, this allows you to reuse code in ways that you couldn't do before. And the last one is potentially another thing you might want to do here is you could reuse this as a component library. So maybe write it in one framework instead of having to write 3 different framework versions of your component library. Just write it once and then export it to Web Component. Or even better, just write it in Web Components without any framework. So I'm going to very, very high level touch on how to use these things. I don't want to alienate 2/3 of everyone every time I talk about one of these. So just kind of bear with me as I go through the framework that you don't like. And I'll have demos of these as well. But for Angular, it's called Angular Elements. And it's using it outside of Angular is not currently supported. It's something that they recommend using only inside of Angular apps because of bundle sizes. So for those of you in the Angular world, you might be familiar with something called Ivy. They rewrote their renderer to be smaller bundle size and information like that. And that's taken most of their time, and so this is sort of on the back burner, but their docs say that they are improving on bundle size. So eventually they'll support using this externally. If you Google Angular Elements and say, how can I use Angular inside of React, you'll see a bunch of blog posts on how to do this. None of them are really officially supported. They're kind of hacks, and I'll show you an example of this, but just be very cautious. You wouldn't want to do this in production yet. So for React, there's no official package. The React community doesn't seem to be overly invested in this kind of thing, which is kind of interesting. And there's a bunch of third-party packages that you'd have to weigh against each other. So my favorite is the Web React Components, not to be confused with React Web Components, or React Web Component with no S, or Web React Components with no S, because they're all different. And I ran into 30 minutes of problems because I installed the wrong one. So make sure you're kind of looking at the plurality of what you're installing. But there are third-party packages to do it. For Vue, I feel bad not talking a lot about Vue in this presentation because Vue, it's natively supported by Vue. It's simple. You just give it a flag in a build CLI here. I just say target WC, and then I give it a prefix, and then it exports everything to Web Component. Even gives me a demo page of what I just exported, and here's how it looks. So Vue is, I would say, ready for production for this scenario. So let's see an example of how to do this. So what I did is I wrote a really, really simple app in all 3 frameworks. And I over componentized it here. So there's a title component, there's an add grocery component, which is that text box, and then a grocery list component in all 3 of these things. And so what I'm going to do is export these all to 9 different individual components, web components. And then I'm going to mash them all together. And the way to do that is, like I said before, you take the JavaScript framework component, you pass it in the export wrapper, then you get some output here that's kind of this combination of them. And what we're going to do here is we're going to make a vanilla app, which is this gray box, and then we're going to stick a React version of this, Angular version, and a Vue version all on the same page. So those 3 components will be different frameworks, and then we still have to import all 3 of the runtimes. So would you ever do this? No. And what we're doing here is, we're creating a monster, right? This is terrible. You would never, ever do this in real life. But it's illustrating the fact that these frameworks can work independently with each other on the same page. And so this is what we're going to make here. It's going to be an Angular title, a Vue add grocery section, a React grocery list. And I'll have this link at the end here too, if you want to take a look at it. And just briefly, like I said, I'm going to be very high level about how to do these exports. There's, on the GitHub repo, there are readmes for each one of these frameworks on exactly what I did. There's no way I'm going to have time to go through all of them. Each one is kind of an independent presentation. So if you have more details, talk to me after, or if you want more details, talk to me after, or go to the readmes here and you can take a look. But this is what we end up with. And if you inspect this, and if you click bread, it'll cross it off like that. If you inspect this, you can see that they're actually all independent things here. So if you're familiar with Angular, it likes to add ng something to your DOM. So here we can actually see this is Angular, it's not faked. And then there's a shadow DOM in here, so everything inside of that is encapsulated. And then similar to that, the Vue likes to add v- things. So you can see that's actually Vue in here. Again, it has its styles encapsulated inside the shadow DOM. And then for React, React doesn't really add much to your DOM, but you can see there's some props and stuff in here, and so it's actually using React under the covers. And then if you were to actually go to the network tab and see, it's actually downloading tons of stuff that I'm not on the network, so that's, hopefully I don't need to refresh anything. I don't think I do here, so okay, I think I'm okay. So let's look about how to do this. Like I said, I'm going to be very, very brief on these things. I'm just going to show very high level the differences between the frameworks and how to do this. So for Angular, the entry point in an Angular app is app.module, and there's generally something here called bootstrap component that is the component you want to pull up when you load your Angular app. And the way these blog posts tell you to do this export is you remove the bootstrap, so you can no longer even run this app anymore. And it's now sort of converted into this mode where it's just exporting web components. So you have to put an empty bootstrap down here, and then you import something called create custom element, which is that wrapper I talked about. And then you pass in the component, the dependency injector for Angular, and then you give it the tag you're going to use, and then that wrapped component. And so now when I run this through the Angular CLI build, which there's instructions on how I did this. It's a little bit messy. But the way you do that is you run it through the Angular CLI build, you get an output, and now I just include that output on a page, and I can just use Angular title now without any problems. I don't have to bootstrap Angular first. So that's an oversimplification of how to do it. There's some complexities involved there, but it works. So for React, it's a little bit different. Some of this I simplified and changed the code in ways that you maybe wouldn't have to do in production. So I was importing a PNG file here. If you were using something like Webpack, you could probably add a plugin to inline this for you. But for me, I just base64 encoded an image here just to simplify things. And then I also had to remove the global import of the style here, because when you do this import on line 8, it's actually making that CSS available globally in React. And the thing is we're using a shadow DOM, and shadow DOMs do not care about what you have globally. It only cares about its little section of the DOM. And so if you left that there, it would not style any of this component. And so for purposes of the demo, I'm inlining the styles. You would probably want to do some sort of Webpack thing where you read this import and then inject it inside of your web component. But for purposes of the demo, that's what we're doing here. And this is where the styles get injected. Again, you'd probably want to do some sort of build step to do that. But all we have to do with React is we import this register function, which comes from web React components with an S. And then you pass it the component, the tag, and then the list of props that we want to listen for changes on. Again, pretty similar to that observed attributes that we saw in the vanilla example. And then for more complex cases, like grocery list, in the kind of native React example, I had a prop that you pass in that's a callback. And React handles callbacks and events quite a bit differently than other frameworks. You know, it has this whole synthetic event thing. And so the way the wrapper handles this is it makes you pass, if you have a callback like this, it makes you pass in the name of the callback, and then it says anytime that's called, I want you to actually emit a custom event instead. So remember I said that vanilla JavaScript web components just use custom events, custom DOM events. That's what this is doing. It's mapping the React event to a custom event. So it's much more web component-y. And there's a lot of work that they're doing in this wrapper to handle all that. So it's pretty helpful. For Vue, again, I feel bad not talking about this much, but there are 0 changes to the code I have to do this. I just say Vue CLI service build, target WC, give it a prefix, so I'm using Vue WC because it got confusing when I had 2 Vue.js files. And then you pass it the list of Vue components. And the cool thing about Vue is you output that, it goes to this dist folder. There's now a demo here that it generates that just has all your web components on here. So if I had, you know, 15, a component library, right, and I just exported this, it would just show me all my components automatically as part of this build. So it works really, really well. There's really no issues with it. It works really well. Okay, and then what we're going to do here is put these all on the same page. Remember in that vanilla example, we used the script tag to do the imports, and that's exactly what we're going to do here. Right? We have everything exported. Now we're going to combine all this stuff together. And so I said we have to import the minimal runtime. So we import Vue minimal runtime. We import React minimal runtime as part of this React components. The Angular version, like I said, is not intended to be used the way I'm using it. So you end up having to import dependencies in a different non-ideal way. When they change this, ideally it would be a minimal runtime for Angular as well. So I wouldn't be too concerned about this. But you're having to import all of the Angular dependencies without tree shaking, so these are pretty large. Then there's a JavaScript file here that's just going to be the thing that kind of maintains my data. And then this is all the HTML that we have. Everything is encapsulated inside of those framework components inside of web components. So there's an Angular title, pass in the text as an attribute. There's a view add grocery, and there's no props or anything or attributes passed in there. And there's a React grocery list with nothing passed in. Okay. Then when the page loads, what we're doing here is we're adding an event listener for grocery added. So remember I said Vue and Angular and React, what they do is they have to convert these events to regular DOM events, like a custom event. And so all this is doing now is listening to a regular DOM event, just like we were doing with the vanilla example. So it listens for the grocery added, it updates the data service, and then it gets the grocery list element, which is up here, this React grocery list. And then it says your items are now equal to these new items. One thing to note with web components, you cannot pass in complex objects to a web component via attributes, like you're probably used to doing in frameworks. And so what you end up having to do is the wrappers will provide the ability for you to add them like this. So saying .items for this React component, the wrapper, I believe, stringifies it, puts it in the attribute, and then parses it on the other side. So it's a little hacky, but it works. And actually, you can see that here. I refreshed it, didn't I? Well, I guess you can't see it. But if you were looked at it, and maybe you remember seeing it, but the attribute items in the HTML had just a stringified version of an array. So that's really what it's doing here. And then again, the React version, when it's item clicked happens, if you remember, we had to do that mapping when we called the register for React. And it's just bubbling that event up, and now we can handle it and pass in the new list of items. So this is all very, very vanilla JavaScript. All the magic is happening in the wrappers and the JavaScript framework components. So limitations, as you might have guessed, there are limitations. For Angular, I already mentioned quite a few of these. There's no ability in Angular CLI to do this kind of an export yet. Either your app will do exports or it will run your app. It's not going to do both right now unless you have some sort of module replacement thing set up. It's not really intended to be used outside of Angular at the moment. Again, their docs say it will be eventually. It's just not right now. Must handle your own build. At the moment, again, these are all kind of temporary limitations. And then significant number of prerequisite packages. So for those of you that use Angular know that Angular has a lot of packages that it likes to pull in, and then it tree shakes them all out. Well, if you're using it the way it is now, you end up pulling in quite a bit of those packages that you're not going to end up needing. But long term, as long as it's part of Angular CLI, it would be improved. With React, the biggest real limitation here is that there's no official support. So the one I mentioned that I was using in this demo, Web React Components, I think was the one, there's like 200 downloads a week or something on NPM. So if you start using this in your main app and rely on that, and then suddenly those developers stop working on it, you're going to be in trouble if something happens in React and they have to change that code, right? You might have to open a pull request or fork it yourself, so you may end up owning some of that wrapper. So it's a significant risk that you have to understand and kind of compare and see if it's worth the effort. You also have to have your own build process, which is a little bit not as big of a deal with React. There are things like Parcel that are a little bit easier to understand than Webpack, and that's what I'm using in this demo. It's a very simple build that can do it. And then React and Web Components aren't really 100% compatible. So there's a website called Custom Elements Everywhere. It's a pretty neat website. It has a set of tests that it runs against frameworks you like, like Angular, AngularJS, and then it runs it against things that at least I have never heard of, so whatever this is, and then really old things like Dojo, and then a bunch of other things here. And if you scroll all the way down here, you get to Preact, and you see it starts to fail some of these tests. Then you get to React, and it's failing all the advanced tests. And then it has a neat little thing on the right here that shows all the issues in GitHub that you can look at and see their progress. And you see there's an RFC for how to fix most of these things. So it's not like React doesn't care about this scenario. They do care. It's just there's a lot of things they need to go about fixing in a way that's scalable and non-breaking. And so that's what they're looking at doing for that RFC. In general, though, the main issues are some of the ways it handles Booleans that are passed in, and then the synthetic event system that it uses. And that wrapper that I showed handles these things for you. So it's kind of resolving some of these problems. So you maybe don't have to care too much about these. I'll get to you one sec. Yeah. Yep, Svelte is good too. In fact, Savelle, I believe, has the ability to do this with a library that's officially supported. So I don't want to discount Svelte. I didn't investigate that. Are you giving the talk on Svelte? I'll be there because I don't know anything about it. But other libraries do support that kind of thing, especially I think Stencil and some others have very similar things to this. So another limitation that you might run into is if you try to combine React and Angular on the page, they fight. And the reason is they're both using Webpack under the covers. If you're using Create React App and Angular CLI, they both use Webpack, and they must use some sort of default setting or namespace. And if you put them minified versions on the same page of your application, you're going to get stack flows that start calling each other. So you'll see like Angular calls React, and then React calls Angular, and it's just this big garbage fire. And the reason is because both Angular and React have issues on their GitHub about this. They're not setting sort of this namespace variable, so everything, it just uses default Webpack variables. So the way to work around this is you either have to make your own Webpack config or use another bundling tool like Parcel I had mentioned. And so that's what I'm doing in this demo. But just be on the lookout for this, because this is probably a common use case that people might want to do, is mixing kind of the two bigger frameworks. Then Vue, I honestly couldn't find a limitation that was because of Vue. Web components have limitations. Like I said, you can't pass in complex objects to attributes, but they're not Vue's problem. They're just built into web components in general. So really the big question here is, should you end up using this? And the answer is maybe, right? And this is kind of something I came up with to give a brief overview, because I don't want to tell you to go to use the Angular elements and then get you in trouble, because you shouldn't. You should wait for Angular. It's okay to experiment, search the web for how to do this, or look at my example of how to set this up. It's fine to experiment. Eventually it'll be supported, but it's not really for production yet, unless you're using it inside of another Angular app. Vue, like I said, fine for production. It's supported. With React, you can use it for production, but I would make sure that you go and understand the limitations that you're getting into from that custom elements everywhere website, and then compare the third-party packages. So I did some initial comparisons and tried some things out, and the one I picked is the one that has the most recent updates and the most committers, but there are other ones out there that maybe suit your needs better. So maybe do some reading on React before you start using it. There's also a bunch of things that I did not look at that you definitely should if you're going to use this for production, right? Performance, is this wrapper going to add another level of complexity in your performance structure? Is it going to start doing a bunch of Angular change detection that you didn't know was going to happen? Is it going to cause a bunch of new renders in React and similar concepts in Vue? You have to probably figure that out. Maybe try scaling it up on a page before you go all in on this. Is it unnecessarily complex? Do you really even need to do this, or are you just doing it because it's fun, which is what I'm doing? Is it maintainable, right? I mean, if you have a team that maybe is lesser experienced, is this something that is going to cause maintenance problems? Bundle size is a big one. Every time you do this, you're introducing another framework into your bundle. A lot of the frameworks are pretty good about making a really, really small bundle, but it's really easy to include things like a state management tool. And if you're using like state management in the Angular side and then state management on the React side, you're ending up including two, and that's going to be pretty heavy on your bundle size. Business need pretty much goes along with maintainability and complexity, but I think the most important one is if this is temporary, right? If you're using it for an upgrade path from something old to something new, make sure that you understand that it really should be completed. This is not really a long-term solution for anything, right? You don't want to put multiple things on the page unless you absolutely have to. So probably nothing is worse than maybe an AngularJS app that you're trying to upgrade, except for that sticking in the middle where you have half AngularJS and then half Vue, right? That's going to be kind of a maintenance nightmare, and the next people hired after you are going to be angry with you. So alternatives, there are actually really good alternatives. If maybe you don't even really need to use a framework. If you're just making simple things on the page and you're not really using routing, you're not using any kind of complex state management, maybe just use a vanilla JavaScript web component. What I showed you is really terrible, right? Using that document.create element, that kind of thing. There are packages that make that way easier. So one is lit element by Google. If you use that, you can do something that they have this HTML, and then you pass in a template literal, and that just gets rendered on the screen. You just give it HTML and it gets rendered. It's very similar to like JSX. And then Skate.js is another package where you can actually use JSX to render just normal web components. So there are definitely ways you can make regular web components way easier to build. So ideally, what I would like to see, and I have no clue if this is possible or if anything is heading this direction, but I would love to see basically the ability to author components in any framework, exporting it to a common runtime, and then that runtime is just vanilla JavaScript. Get rid of React, Angular, and Vue in that export, and then consume it by all browsers. So there's nothing out there that I know of that does this, except maybe some of the other frameworks. I don't know about Svelte and Stencil. Maybe they do this already. But this would be ideal, right? It would be similar to something like .NET, where you're writing in a bunch of different languages and you're exporting it to something common. It would be great if the web could do this, because we could all stop freaking out every time there's a new framework. There are a lot of references out there. These are some of the ones I used. these are all in the slides. Obviously, you can get them. You can search for them. I'll leave it up here for a few minutes, and then I'll have the next slide here that has my my slide, talk, the demo URL, and the repo on there as well. So with that, does anyone have questions or comments? Yeah, the question is any interoperability with the React Native world. I'm not sure. So I've never done any React Native, so I don't know. Are you talking about putting something inside of React Native or the other way around? Or?
I guess either.
Okay.
Because like this is, I think this is like really tempting, this idea that like we could have one standard that just everything exports to.
Sure.
But there's a ton of development happening in React Native now,
Yeah.
which is compiling to something that is not HTML or JavaScript.
Right. So I don't know much about React Native, and if you could use this with that, I suspect there's some other complexities involved that maybe make this a little bit harder to do. I would think it would probably be more likely to be used where you're putting stuff inside of React Native than exporting something outside of React Native. But you can try it. The way I would suggest trying it is just spinning up a Vue app real fast. Just doing a hello world and then exporting that, because that process is like 5 minutes, and then stick it in your React Native app, see if it works.
I think the issue with that is that web components are targeting the browser DOM.
Yeah.
React Native doesn't care about that.
Sure.
So I wouldn't see that happening.
Yeah, the comment was, React Native's not targeting the browser DOM. So that's the part I don't know about React Native. I know in Angular, if you're going to use something like native script, stuff like document dot or window dot is a no-no. But I'm not familiar with React Native enough to comment on it. Yep.
If you're using it as a transition plan between frameworks, how much of an effort is it to move back into the full native framework once you're fully transitioned?
Sure. So the question is, if you're using this to transition, how much of an effort is to kind of complete the transition? Is that right? So if you're today, if you were going to go start this today, with Vue, I would say there's minimal effort. You don't have to do any code changes. With Angular, hopefully that'll be the case. It won't be any kind of transition path that's really important enough to mention. React, I'm not 100% sure. You'd probably have to experiment with how to do that. But the main piece you're missing when you do these exports is you need that wrapper app, right? When you're done making every little piece of component, you have to replace the old framework's main, router and all that kind of stuff with the new one. And that's not really something you would export. So I guess that would be the piece probably when you're ready to finish it that would take the most time, if that makes sense.
You described an ideal feature, and I think another ideal feature would be that working in web components is so easy that we just drop all the other frameworks and everything is straight web components. So what are we missing that stops us from doing that? So it seems like it's a big thing. There's browser support, not quite there across the board yet. Tooling support, not nearly as good. I did a bunch of work in Polymer and it was a nightmare in terms of tooling support, telling me when I did something wrong, not telling me. And then the last thing is I think there has to be a syntax that makes it so it's easier to implement in web components than it is in the other frameworks. We're not there yet, but maybe some of the things you mentioned, like what was it called, lit?
Yeah, so I'll touch on a few of those quick. So the question was about, what's stopping us from just using web components for everything. And there are a few things. So browser support, potentially is one of them. There are polyfills for older browsers. And there are things where you can make it so that only older browsers pay the price for those polyfills. In fact, Angular does that now in their CLI. They export 2 versions of their build where all the old browsers have to pay a bunch of extra cost. And the way they do that is with some new features in browsers. So I think browser support is there. I mean, your older browsers, yeah, they're going to have to pay for it. In terms of using it, the syntax, like I showed you, that basic web component syntax is pretty ugly, right? Lit element is really fantastic if you look at it. It's by the Polymer team. So maybe take a look after, we can chat, and I can show you an example. But it's basically like writing a framework component that you're used to in React or Angular. And similar with Skate.js, it just makes it way easier to do. And eventually, I think some of those might be part of the main browser spec eventually. But for now, these are just very, very small wrappers that just handle really basic rendering for you. So that would solve a lot of the problems you're talking about. But there's still issues like routing and that kind of stuff that you're going to need a package for. So there are still reasons to have a framework. It's just maybe not for everything. Also, there's the whole concept of micro front ends that people are talking about now. This is sort of one way to do it potentially. I don't know a lot about micro front ends, so if someone wants to talk to me about that afterward, that would be great. Yeah, I built a hyperactive micro front end. But yeah. Any other questions, comments? All right, thank you.